Welcome back, everyone. Ready for another deep dive? Today, we're going to try to get our heads around something pretty mind-blowing. Quantum computing. It's one of those things that sounds like it's straight out of Star Trek, but it's actually becoming more real every day. We're going to unpack what it is, why it matters, and how it might just change the world as we know it. And to help us navigate this, we're diving into a really interesting Forbes article, From Bits to Qubits, The Future of Quantum Computing.
Yeah, it's a pretty fascinating time to be digging into this stuff. The article does a good job laying the groundwork, but what really gets me is the sheer potential impact quantum computing could have. This isn't just theory, you know?
Absolutely. So the article kicks off with this idea of a qubit, which is kind of like the basic building block of quantum computing. And they use this analogy of a spinning coin, which I thought was so smart. You know, when you spin a coin on a table, it's like it's both heads and tails at the same time until it finally falls flat.
Yeah, that's a great way to explain superposition, which is like the heart and soul of how quantum computers actually work. It's like this. Think of a regular computer bit like a light switch. It's either on or off, 1 or 0. But a qubit, on the other hand, it's like a dimmer switch. It can be a bit of both, 1 and 0 at the same time because, well, quantum mechanics.
So instead of just two states, a qubit can be anywhere in between, right? That's where the real power comes in.
Exactly. And this is where it gets really cool. See, because a single qubit can explore all these possibilities at the same time, quantum computers can tackle certain problems way faster than traditional computers. It's like imagine being able to consider every single option all at once instead of going through them one by one.
Wow, that's kind of hard to wrap your head around. But how does that translate into, like, real-world stuff? It still seems kind of theoretical.
It might sound theoretical, but the article gives some really practical examples. Imagine, like, trying to choose a restaurant with your friends. A regular computer, it would have to look at each restaurant one by one, considering the food, distance, price, all that. But a quantum computer, it could analyze all those things for every single restaurant at the same time.
So instead of giving you a bunch of options, it could tell you the absolute best restaurant for everyone.
Exactly. And this ability to handle tons of data and crazy complex calculations could completely change fields like finance. The article mentions how quantum computers could revolutionize things like risk assessment and fraud detection by analyzing market trends and spotting anomalies incredibly fast and accurately.
Right, because finance is all about predictions and patterns in data. So if a quantum computer can analyze all that data way faster, it could give investors a huge advantage.
And it's not just about speed, it's about tackling those problems that even the most powerful computers today just can't handle.
So where else could we see this kind of quantum leap, so to speak?
One area that's super exciting is pharmaceuticals. Just imagine designing and testing new drugs at the molecular level with like pinpoint accuracy and at lightning speed.
That would be incredible. Talk about developing new treatments, especially for diseases that are really tough to crack right now.
Oh yeah, I mean, we're talking about potentially changing the game for drug discovery. Instead of having to go through that whole trial and error thing in the lab, which takes forever and costs a fortune, scientists could use quantum computers to, like, simulate how molecules interact, and they could do it with incredible accuracy.
So they could basically design and test new drugs virtually before they even try anything out in a real lab.
Exactly. It can make the whole process so much faster. We're talking about new treatments for diseases like, Alzheimer's, cancer, HIV, things that are really hard to treat right now. We could see those treatments way sooner than we ever thought possible.
It does sound almost too good to be true, right?
Yeah.
There have got to be some challenges. I mean, building these quantum computers can't be easy.
Oh, absolutely. It's not like we've got it all figured out. Building these things on a large scale, it's a massive challenge. The article mentions this thing called quantum error correction, which is a major hurdle right now.
Quantum error correction. Okay, that sounds intense. What is that?
So qubits, they're really, really sensitive. Even the tiniest change in temperature, like a little vibration, anything like that, it can mess up the calculations. And those errors, they can add up and really throw things off.
So it's like those old calculators where if you typed in one wrong number, the whole thing would go crazy.
Yeah, kind of like that. So quantum error correction, it's basically trying to find ways to catch those errors and fix them as they happen, in real time. Because if we want quantum computers that actually work for real world problems, we got to get that right.
Yeah, that makes sense. Sounds like researchers have their work cut out for them. But I guess any new technology, especially something this big, it's going to have some growing pains.
Oh, for sure. It just remember when the transistor was invented? It was just this weird little thing. Nobody really knew what to do with it at first. And now look, they're everywhere. Your
Right.
smartphone, the laptop I'm using right now, none of that would exist without the transistor.
That's a good point. Sometimes it takes a while for people to figure out how to really use a new technology, to unlock its full potential. You say
Mhm.
you think quantum computing is kind of like that?
Exactly. We probably won't have quantum computers sitting on our desks next year, but over time, their impact is going to be huge as they become more powerful and we figure out this error correction thing. We'll see big changes in all kinds of fields.
And that gives everyone time to adapt,
Yeah.
right? Figure out how to actually use these things. It's not like we could just flip a switch and suddenly everything's quantum.
Right, it's more of an evolution than a revolution, which is a good thing. It'll make the whole transition smoother, more sustainable.
So maybe we're not teleporting anytime soon, but things are definitely about to get really, really interesting. So we're talking about some pretty big changes here. And it makes me wonder, what about things beyond finance and medicine? The article also talked about how scientists are working on even larger, more complex quantum systems. What does that mean? What's the big deal with size?
Well, think of it this way. You've got a bicycle, right? And then you've got a high-speed train. They can both get you where you need to go, but the train, it can do it so much faster, and it can carry way more. It's kind of like that with quantum computers. These bigger systems, they'll be able to handle much tougher problems. We could see breakthroughs in things like, material science, artificial intelligence, even climate modeling.
Wow. So we could be talking about solutions to some of the biggest challenges we're facing. It makes you wonder, how will all of this affect us in our everyday lives?
That's the million-dollar question, isn't it? How will these advancements actually trickle down and change things for everyday people? Imagine a world where personalized medicine is just the norm, where treatments are tailored to your specific DNA. Or think about new materials, things that are lighter, stronger, more sustainable. That could revolutionize everything from how we build houses to how we get around.
It's really kind of mind-blowing when you start thinking about the possibilities. This whole conversation, it's like those science fiction books I used to read when I was a kid. Back then, it all seemed so far-fetched, but now it feels like we're actually on the verge of making some of that stuff real.
Yeah, it's that sense of wonder, the feeling that anything is possible, that makes this field so exciting. And the best part is this isn't just happening in one place. It's a global effort. Universities, big tech companies, startups, they're all racing towards this quantum future.
It's amazing to think about all the brilliant minds working on this. So, as we wrap up our deep dives into the quantum realm, here's a question for you listening. If quantum computing could change one thing in your life, what would you choose? What's the one thing you're most excited to see change?
Yeah, what possibilities really capture your imagination? What breakthroughs would you love to see happen in your lifetime?
Think about it. Because the quantum revolution, it's just beginning. And who knows, maybe you'll be one of the people leading the charge. Thanks for joining us for this deep dive, everyone, and we'll catch you next time.